Hello, welcome to the rubberduckdevshow. I'm Creston,
And I'm Michael.
and today we're going to talk about Postgres features, specifically explain, analyze, and probably a little bit of PG stat statements as well. So, developers who are interested in Postgres, this is an episode for you. But before we get into that, typically we talk about our weekend review. So, I'll go ahead and start first. So, been working diligently on my scaling Postgres course, my performance optimization course, basically, and also doing a lot of plate spinning because I have a lot on my plate with a couple of different shows and consulting and my product and all these types of things. So trying to find the time for everything fitted in is really quite hard. So a lot of spinning plates this week, but still doing the best I can to do the work and get the course across the finish line in an acceptable period of time. But that's me. What about you, Michael?
Nice. Sounds very familiar. Also working a little bit on my product, adding, improving a tip we have around slow planning time. So that's I've been in the weeds of that, and also recording. Also do a Postgres related podcast. So just started doing guests on that this month, and have four of those lined up. So two just recorded, one edited and published, and two to record. So lots more editing work ahead, sadly. But I'm looking forward to those conversations. But I need to prep for those as well. So yeah, plenty of plate spinning, a couple of smashed in the background, but
Try not to
all
show it
good
to
at the
others.
moment. Right.
Yeah. I need to get on and I need to book a lot more guests as well in the future. I kind of do just in time booking, which is it's not great. So I could definitely feel with you with that. All right. So let's go ahead and get started talking about Postgres. Before we get into that, do you mind giving us a little bit of your background about how you got into Postgres, like where you kind of came from to start learning about it?
Yeah, sure. And I'd love to hear yours as well in a moment. So my background, I actually studied maths at university and ended up working at a company called Redgate Software, who make a lot of developer tools and database tools, but mostly at the time it was for SQL Server and Microsoft SQL Server.
Right.
And I ended up but they used to do these week long, they called them down tools weeks, where the whole development team got to work on whatever they wanted for a week, that as long as it was like somewhat helpful to the company. And one of these weeks, one of the developers worked on a tool for doing an equivalent tool to one of our more popular tools, but instead of for SQL Server, they did it for MySQL. And then later down the line, a team built a product for Oracle, and I ended up leading the team that ran those tools, so the Oracle tools, the MySQL tools, and we kept seeing Postgres come up in conversations. And I think I was there for 5 years, but I think if I was there for a bit longer, hopefully we could have persuaded management to give us a bit of time and a few people to build the tools for Postgres as well. Um,
Now,
but as it
what
happened,
did I'm sorry, what did some of these tools do?
so the more popular ones that we built for the other databases as well were around comparing databases and source controlling the schema. So you
Okay.
could compare schema and deploy between, let's say, let's say there was an issue on production that you hadn't seen in staging, or the other way around. Compare the two, see what differences there are. Um, Version control those changes. If you want to compare the data, sometimes you want to do like a deployment of data, or sometimes you want to. But anyway, there might be data differences between two databases that should be the same. That tools for comparing and deploying those, and version controlling the schema
Yeah,
they were the big ones that we did.
like a diff on steroids, but for databases.
Yeah, exactly, and kind of migration aware as well. So just diffing that you might uh, not want to do a diff in a certain way. Let's say you notice that a table in one you might not want to do a certain type of deployment. You might want to make sure it's not going to take production down by running that script. And the order matters as well, right? You can't just run migrations in any order. So there's some logic behind
Right.
those as
Right.
well.
Yeah. Okay. So you were doing that at Redgate, and you heard, Postgres was a desired additional platform to add for the tooling. So where did it go from there?
Yeah, and then this was like 2010 to the end of 2014, and then I moved to a startup in London. So this was up in Cambridge in the UK. And then I moved to London and worked at a company called GoCardless who do payments.
Yep.
But
Yep.
they were big Postgres users and loved it, and the team there their enthusiasm was infectious, and it was a really impressive team. I learned a lot from. I was only there 2 years, just under 2 years, but I learned so much from the people there. And them being such big Postgres advocates made me realize it wasn't just large companies trying to save money moving to Postgres, but it was also startups picking it as their database to scale on. It was being picked not just by old kind of cost conscious companies, but by new growth focused companies too.
Okay.
So yeah, that was then my first kind of experience seeing it being run in production, and then but I wasn't involved. I wasn't in that team. And
What
then
were you doing at GoCardless, for example?
yeah, all sorts in the end actually. But I went. I was supposed to be going to do product management, which was the main thing I did at the previous company. But I ended up then. Startups are a fun world. There were only 35 or so people when I joined, and what they ended up really needing was somebody to run their customer success of all things. So I ended up running customer success there for about a year and a bit before going back into product management somewhere else.
Okay.
So yeah, it's a funny world, but yeah. Then basically, I had it in my head that Postgres was a really cool platform. I loved that it was open source. And it felt like a good platform to build for. But so yeah, I did want to someday build software that I could run myself or build software for developers, and Postgres seemed like a great platform for it. So in spare time, in kind of evenings and weekends, started interviewing people and finding out like what should we build, like what could we build that would be useful, and with a friend built PG Mustard in like evenings, weekends, 1 day a week, that kind of thing. But yeah, what about you? Have you answered this before on the show, or how did you get involved with Postgres?
I think I've probably answered it somewhere. I can't remember where, but basically, I've mentioned this multiple times, but in different shows and uh, in different ways. But I actually started doing, I guess my earliest kind of technical thing related to databases is I was doing a conversion project. So I was actually a project manager, and they needed someone who knew something about the databases. And a little bit before I was a project manager, I had a lot of systems administration experience. So not so much a software developer, but like setting up computers, setting up servers, configuring them, optimizing them, things of that nature. And we kind of needed a DBA of sorts. So I kind of took on those responsibilities, and it was for Microsoft SQL Server. So I did
Nice.
that. Yeah. So I did that in that capacity, and like a part-time project manager, quarter time, or whatever you would call it, database administrator. But in that, I was working for like a line of business unit, basically a fundraising arm at a university. So I started
Mm,
needing to do all sorts of reports. So I really got to understand SQL and all the data, and running reports for people that were asking questions. So that kind of gave me more exposure in that area. I eventually moved to another institution and started using a product that used Oracle. And I kind of got the Oracle DBA responsibilities as well, because again, it was a more technical role. So kind of learned Oracle and whatnot. And then it was in 2009-ish that I started my company, and we were going to be doing a software as a service application that does basically online giving forms, online event registration forms, And so we had to pick a database. And, knowing the price of Oracle around that time or Microsoft SQL, we weren't going to be using the Microsoft platform, didn't have money for Oracle. So it was only going to be MySQL and PostgreSQL. So basically, I gave the opinion, even though like at the time we were using Rails and a lot of Rails, like I think Basecamp was using MySQL, but I'm
Yeah.
like, I like the fact that PostgreSQL at least had functions or something semi approximating stored procedures in Oracle and Microsoft SQL Server. So it just felt more mature in that area.
Hmm.
And I think that was probably the main reason, but it was still a little bit of fate. I don't know, probability that I said, all right, let's use PostgreSQL. So basically, I took my knowledge, DBA knowledge, and applied it to PostgreSQL. So that's kind of how I got started with PostgreSQL. I never used it at any company before the one I founded in 2009ish. So that's kind of my background.
Wow, that's cool.
Yeah. So, so what are you? Do you use any other databases, or is pretty much pure PostgreSQL?
No, I think. Well, first, yeah. For I also run a software as a service business, and we try to keep the kind of minimum amount of data we can. So as much as I sometimes am tempted by the allure of having lots of data and therefore giving ourselves performance problems just to be able to, use the product a little bit more for ourselves. Um, no, mostly we just don't store much. Therefore, we don't have much data. We do use Postgres because it'd feel mad not to. Um, but I do the one database I am keeping an eye on because there's one database and one kind of tool that I'm keeping an eye on. The database is SQLite. I'm fascinated by what the kind of how people are pushing that database at the moment. It feels like a lot of energy around that and a lot of impressive engineering behind it as well. Normally for different use cases than Postgres, but increasingly like maybe not, which is interesting. And then the tool that's got DB in the name, but I'm not sure you could call it a database, is DuckDB. Looks really impressive for
Oh
doing
yeah, yeah, yeah.
some,
So
yeah,
these are probably used for
analysis.
more local or embedded solutions, I guess. Not
I mean,
100%, but yeah.
that's what they were designed for initially, but increasingly, you can host them server side. There's no reason you couldn't.
Yeah, I
And I'm
mean,
I'm seeing, yeah.
yeah, thinking about that, I any open source project, it's kind of where the core committers want to take it. So it can go
Hmm.
anywhere. I mean, that's what's happened to Postgres, that it has this huge feature set, is because people said, I want this, I need this, I'm willing to commit to the code base to do it. And that's where it comes from. Yeah. I mean, my only exposure to SQLite is basically Ruby on Rails. That's kind of like the database you don't have to configure, and it comes when you're doing a development project. That's like the default database for it. So I used it insofar as that. But yeah, that's my only exposure to it. Are you using
Nice,
it
makes
for?
sense.
Are you using that for other particular purposes, or you just find it fascinating in
Yeah,
terms
I
of
find it
another
fascinating,
database
and
listing?
also
Okay.
as a tool builder, I think I'd love to run my own company for like decades and live my whole career, well, this part at least, after working for other people, work for myself, ideally for the rest of it. And I'd love Postgres to last that long, and I personally am betting on it. But you do need to keep your finger on the pulse a little bit and see, if something was to replace this in 20 years' time, what would it be? What would it look like? We're probably still going to have similar data patterns, and if the past is anything to go by, we're probably going to end up with bigger volumes in the future. But what we use to manage it might be different, and if so, what does that look like, and what would people be using for businesses like ours in the future? What would a simpler thing look like? What would a cheaper thing look like? And what tools do those people need? Is normally
Yep.
like the next question. So That's why I try and keep my finger on the pulse a little bit. But yeah, talking of the Basecamp guys, I think I saw DHH tweeting about SQLite performance. I think they're using it for their once products, the new
Right.
non-software as a service products that they're letting people install themselves. And it's a nice thing that you can package alongside your code, and you have the database there, and they're like sitting right next to it. People don't have to manage it separately. So it's an interesting use case.
Yeah, yeah. I'll have to look at that. I haven't looked at that recently. Um, yeah, but this is probably a good segue to kind of talk about explain, because this is of course related to your product, and that's PG Mustard. So feel free to talk about the product as well. But you said in terms of a topic, talk about explain, and so why is that important? Why does someone need to know about that? At least insofar as using PostgreSQL.
Yeah, and I think this is part of your course, right? I linked to you had a few lessons, and one of them was on the very basics of explain as well.
Yeah.
So it comes up normally for performance reasons. So if you put the word explain before your query, if you put explain, then you're normally a select query, but any update, delete, and execute that, instead of getting the results of the query, or even instead of executing the query, what it will do instead is show you the execution plan. So how Postgres would get you that data or do that operation. And that's really helpful for performance reasons mostly. So knowing what choices would it make. So often, because SQL's a declarative language, we say what result we want. We don't specify the algorithms to use. Postgres uses a cost-based optimizer to say, I have these. Maybe it doesn't have any options, by the way. Maybe a query can only be executed one way because you don't have any indexes, and you're querying all of the rows from a small table or something like that. It only has one choice. It won't spend long planning that query because it only has one route. Here's the plan. We're going to scan the tables sequentially, and maybe we'll stop if you put a limit there at some point.
Right.
But often, if you're joining multiple tables, it can choose which order to join those in. It can choose which strategy to use to join those. It could choose which scan type if you have indexes. So there's a bunch of choices that it can make that are really important for performance reasons. Joining tables in a certain order can make a huge difference to the performance of a query. Choosing an index scan over a sequential scan can be a massive difference. So knowing what choices it's making can help you then work out why it's making those choices, or things you could do to make it faster. So yeah, that's why it's normally performance related that you're looking at this, but I guess it could be for other reasons as well.
Yeah. I think I probably only use it for performance reasons. I'll have to think if there's any other reason I would. Um, yeah. So in terms of explain, so you also mentioned explain analyze. So how's that a little different?
Yeah, so explain analyze will also execute the query behind the scenes. Now you won't get the results back in yourself. You'll get a similar looking query execution plan, but with additional performance data. So the one that stands out to people, the one that's super valuable normally, is the timing data. So you get not only the time that the query took to execute, but also each operation that it did. For example, each scan that it did, or the join operations. How long did each of those take? And that lets you look into where was the bottleneck, or was there one bottleneck, or were these all kind of roughly, lots of things that took a little bit of time. So that can be extremely useful for diagnosing a performance issue. So that's why explain analyze comes up a lot. Analyze is just a parameter of explain, and it's a bit confusing because some people might be familiar with, there is a separate analyze parameter for
Yep.
Postgres that's used to gather, it's performance related as well. It's used to gather statistics to help the query planner. So it is a bit confusing. So if you've ever heard vacuum analyze, that is the same analyze. as regular analyze, but it's though neither of those are at all related to explain analyze. So yeah, difficult medium to explain that over, but maybe that's a blog post that needs to be written. So yeah, but that's only one parameter of explain. It's probably the most useful. Yeah, I'd say it's definitely the most useful parameter for explain. But there's loads of other useful ones as well. Buffers is one that I'd love to see on by default with analyze. That gives you information about the amount of work done by the query. So not just how fast it was, but like the data read and where it came. Like, was it in memory, or was it potentially, did we have to go to disk for that? Did any kind of big operations spill to disk? Information like that you get via buffers. Then there's also verbose there's loads more settings as well. And yeah, each of those are just parameters for explain to get more information back.
Yep. So I hate
I've
to
got a
admit it,
question
but
for you.
oh, sorry. Go ahead.
Well, what do you, when you use explain, do you tend to use explain analyze, or do you use more parameters? What's your kind of default
I
settings?
was going there. I said I hate to say it, but I pretty much just use explain analyze. I rarely use buffers because I don't know. I mean, my perspective is okay. Where's the slowest node? What's the slowest bottleneck? And I just typically use the timing. I guess if it's only if something I'm having trouble understanding about why something is happening a certain way, I might throw in buffers. And I know I've read multiple blog posts. I've heard people talk about that, buffers should be, as you say, a default. I was like, okay, but I just, in terms of where I look on the resulting query plan, I basically look for the node timings for the most part. And it's kind of funny, like reading an explain output. When I look at it, I remember back to have you ever seen the movie The Matrix?
Yeah.
And there's the point at which
Yes.
the guy is looking at the code going down, and he says, "How do you read the code?" Or "How do you read the?" And he says, "Oh, I see red dress, blonde hair, or whatever on the code." And I have a feeling for the people just getting started, and you could correct me if I'm wrong, the feeling that the explain plan output, a lot of people, even new developers, they look at it and it looks like the matrix code. They have no idea what's going on. But once you take a little bit of time to actually understand what each part is, then you kind of look at it, oh yeah, this is slow here because of this, and there's too many loops, or whatever it is. Uh, I may be taking this off a tangent, but do you actually think some of the explain output is a bit, well, challenging for new people? I mean, I can read it now quite easily, but do you think it's challenging for new developers to kind of get a hold of?
Yeah, and that's kind of why we built the product. Like, our
Yeah,
product
the
is,
PG mustard. Yeah, it's
yeah,
to solve that pain
but
point.
it really is. And even people that, like, we noticed, so I spoke to a bunch of people, and also watched a lot of online forums where people were asking performance questions, and there was back and forth and questions. And even when an expert had what looked like all the information, sometimes they had to ask follow-up questions or give choices, like it might be this, it might be that. Or sometimes the experts would get things wrong, like they'd misread it slightly or jump to a conclusion. Like I have to catch myself sometimes, because the arithmetic can be tricky. Like, even if you look at the code, like there's no thousand separators in any of the timings, for example. Sometimes you don't spot that there are a number of loops, and you don't quite like work out that once you multiply that tiny number by that huge number, that
Exactly.
is going to
This
be
1 millisecond with 10,000 loops means 10,000 milliseconds or 10 seconds.
right. Or even like if it's 17 hundredths of a millisecond, and that's times, like you just think fast, and then you see, oh, it's 117,000 loops. What? Like, so these things add up quickly, and it's taxing. But so if you, even the experts we see can kind of load it into memory, and then they can, if they get distracted 10 minutes into looking at a slow query plan, they might have to start again. So there's some of these like stuff that humans aren't as good as computers at, and we're not the only tool. Like there's we were partly inspired by a couple of really good tools. There's a tool by
Yep.
Depeche, sorry,
Yep.
explain.depeche.com, great
I
tool. And
I mispronounced his for years. If you looked at scaling Postgres, my pronunciation of the site name was awful. I just did it by letters, and then I think it was, oh gosh, who was it? I think Lucas Fiddle, is it,
oh
for
yeah,
PG
yes,
Analyze?
PG Analyze, yeah.
On his one of his videos, he says Depeche. I'm like, I'm such an idiot.
I
But
mean,
yeah.
online, I heard some good advice to um, never think somebody's less smart because they pronounce something wrongly. It probably means they learnt it by reading it rather than hear. Like, and
Yeah.
people that read often are some of the, like, people that read a lot, some of the smartest people you'll ever meet. So yes, but I think they're from Poland, so the
Sure. Yeah.
pronunciation should be Depeche. I have said it wrong in a talk before and been politely corrected afterwards by I think it was Vic Fearing in all of his might, saying, "By the way, I think it's Depeche." So
Yeah,
okay, yeah, that makes
it's
sense.
true story. My first or second or third episode of Scaling Postgres, someone sent me a link and said, "You're saying PostgreSQL wrong," and sent me a link that had the audio file of how the community pronounces. Because I can't remember what I used, but it wasn't PostgreSQL, and so like, thank you if you were one of those people that you know kindly say, "I think you're saying it wrong."
Yeah, but also I'm kind of in favor of not correcting people. Like, what, you know what they meant? Like, it's no one that
True.
says
Yeah, true.
PostgreSQL. There's no confusion what you're talking about. I'm all for being kinder, and like, if one of your first interactions with the community is you're wrong, it doesn't feel super welcoming. So yeah, I take your point. It is nice to know how to not sound like you don't know what you're talking about in front of a room of people or something. But the rest of us, I think, once you know, remember we didn't know once as well. And if you
Yeah.
want to cheat, just the simple version of it is just call it Postgres.
That's what I tend to do. I can't how many times I've had to, like, recording scaling Postgres episodes. I just mumble over the words. But yes, Postgres is much easier.
Yeah, I've forgotten where we were. Explain. So yeah, do we like do I see it as difficult to
I
read and
Yeah, and you said that's exactly kind of why you're, building the PG Mustard tool.
well, yeah, so explain.depeche.com and a newer one that's the one that was around at the time that we started was called Tatiant's it was PEV, Postgres Explain Visualizer, much more visual version. The Depeche one preserves the text format, whereas the PEV one makes it more visual. That's been kind of taken over, and a version 2 of that's been built by the team at Dalabo. And both of those tools do a good job, in my opinion, of at least the basic timing calculations. So which operation took the most time if you try and assign appropriate amounts of time to each one. Now, it's not, you can't always break it into like neat numbers that add up to 100%, but they at least take the simplest approach of subtracting each child operation from its parent operations, multiplying by the number of loops. So all the things that we're trying to do in our head when we're reading a text format explain without one of these tools, that's the bare minimum. Like, so first work out where the timing's going. That was a problem, but those tools mostly solve it. Like, there's some edge cases that I've spent far too long looking into. But then there's always that, like, even with those tools, quite often the next step is, okay, that bit's slow, but what can I do to speed it up is
Right.
the next thing. And even people like regular developers, and I'm not talking about Postgres DBAs, but regular developers, even ones with like 15 years experience, really exceptional Rails developer, for example, might only be looking at a slow explain plan a couple of times a year, or like maybe they don't have a performance issue a couple of times a year. And I don't know about you, but things I only do a couple of times a year, I don't remember like the details of. And it's so putting that context back in front of somebody when they need it felt like an opportunity, and helping them with that next step of, okay, so this part's slow, but what can you do about it? Or what are your options? Like, do you have multiple options? Might it be this kind of issue? Might it be that kind of issue? Like sometimes it's not, even with the information we have, it's not obvious whether if you improved for example, the row estimates to help the planner make better decisions, would that change the plan or would it not? Did it have a choice, or would it reach that threshold or would it not? You literally don't know if you're only looking at one execution plan. So giving advice in a way that's kind of treating people as the expert of their own domain and just saying, well, in Postgres, this might be the issue, but it might not. Try this, come back, see if it's improved. So yeah, it felt like there was an opportunity there that could maybe help these good developers that just don't have to use Postgres all day, every day.
Okay.
If that makes sense.
No, yeah. So that's pretty much what the PG Mustard tries to do with regard to that.
Yeah. So yeah, good point. It's we visualize. So we are a visualization tool. We will do it similar to the Dalabo tool. Now it doesn't preserve the text format, so you don't like with Depeche. One of the nice things for experts, and probably like for yourself, you might prefer that tool because you still, even though you get the timing calculations, it still shows you what the text format was on the right hand side. So if you need to fall back to that or want to fall back to that, it's still there for you. We don't, and Dalabo doesn't. But what we do instead is add tips. So on each operation, you'll see a series of issues that might be the case, and then they'll be scored. So depending on how likely they are to speed up your query, a bunch of them will be scored 0. This is unlikely to have any impact, like, or even we call them anti-tips. So like cache performance here was 100%, 0 out of 5. So not like nothing you can do here will help. But the top 3 issues we spot across the whole query plan. So we do a bunch of so it's just an algorithm basically, bunch of calculations, and the top issue, or the one that if a tip could like drastically improve the performance of your query, we'll give it 5 stars. If it's like moderate, it will be somewhere like 3 stars, 4 stars. If it's like could make a small difference, it'll be like 1 or 2. So it's scored tips, and then we'll only highlight the top 3. So here's the first thing to look into. Here's the second thing to look into. And if neither of those helped, here's a last chance, like I guess baseball style. One last go at the problem.
So, out of curiosity, do you keep any metrics about the plans that are input? And do you have an example of like the most insane, how many lines a particular query is that they've submitted? I ask because I know at times, like in my consulting, someone comes to me and says, "Hey, this query is slow," and I look at the explain plan, and it's like 200 lines of explain. I'm like, all right, time to get to work.
Yeah. So 2 answers quickly. First answer, no. We do give people the option of storing their plans with us, but it's off by default. And I'm kind of glad. Like we're quite privacy conscious, and would rather not. Well, you can't lose data you don't have, and query plans can contain sensitive information because you're often pasting the real query into. Like if you want to do performance work, you kind of have to have realistic test data. Realistic test data, until relatively recent, well, it is possible to create. Of course, it is, but most people don't bother. Most people use their production data, so still to this day, sadly, that still seems to be true. So it can contain like PII in your query plan. So, but for those reasons, we don't store them by default. So we don't, and opt-in rate is low. Like we might get 5% of plans submitted get stored. So no, I don't have great stats on that. But the second thing, because we're software as a service, we do like have had the odd case where people have pushed the upper size limit. So bear in mind, I'm talking about JSON format plans, which we, until a year or two ago, we only supported JSON format plans, not text format plans. And the JSON is bigger. So you have white space, but you also have every key and value. And whereas in the text, it's pretty much just values and multiple per line as well. So, and on top of that, we suggest people request buffers, as we talked about before, which actually includes 10 to 12 keys per node. So that 200 line one you're talking about, that's another 200 times 10, so at least another 2,000 lines to the plan. And out verbose as well we put on, which doesn't, despite the name, doesn't add as much as buffers. But it can if there are lots of columns. Like if a query plan, and this is quite common in things like Rails or other frameworks, often the default will be to return all the columns, and some people have very wide tables, and that can, if you're returning all the columns at every node of a 200 node query plan, that's a lot of data as well. But to give you so the short version is the largest query plan we've had submitted so far was over 50 megabytes, which was so that at first we couldn't handle that. We now do stuff like we now do a bunch of compression and stuff to be able to handle that nicely, but it still thinks for a couple of seconds before processing one of those. And this, again, to your point, like processing a 200 line query plan even as an expert is okay. I'm gonna have to ramp up to this, whereas we wanted to build something that maybe gives you a shortcut. Like if it's all one of those 200 lines, is like the entire issue is on one of those 200 lines, which it can be, how do we get you to there like really quickly? And one of the tips I have for people is check the bottom of the query plan first. You'll probably do this naturally anyway, but firstly, the execution time's there, planning time, but also so is trigger related information, which can be the bottleneck. Planning time can be the bottleneck, and so can just-in-time compilation, especially on complex queries. Those are all reported right at the bottom. And if the issue is there, you can avoid looking at that 200 line plan, and just point out, oh, the issue's already here. So there's a couple of shortcuts, but we built the tool partly to be able to avoid people having to look through those two, or at least the computer helping you, like maybe look at this one first.
In that particular case, like that really long one, it was actually, here's where, I had to step back and say, all right, I think the whole premise is wrong, and we need to think how this whole query is. And unfortunately, that's what happens. And you have to rethink the whole thing. And some of that, in the worst case scenarios, goes to, okay, the schema is set up this way, but you're wanting to ask for questions this way. I think there's a little bit of a disconnect in that. If you want faster output, you're probably going to have to make some schema changes, So then there's, it gives you, there's points where you need to step back at point, and say, I mean, it's great when it's like, hey, it's this node, you put the index on this node, voila. But then, like in this particular case, this really long one, I was like, it wasn't changing the data. Like we didn't have to change the schema in this case, but it was grouping and summarization and merging things together actually had to be done in a reverse order to get the best performance. I can't really explain clearly more than that, but I just basically had to rethink how the query was chosen to be processed. But
and that's part of it as well, right? Like, how do you point out when something's pretty much optimal already, even if it's taking 3 seconds? It's like reading it entirely from cache. It's pretty compact, like it's efficient read wise. So this is where the buffers come in. You've not got a bloated table or bloated index, but you're returning 30,000 rows, or you're doing a count over them, or you're doing some big aggregation, and you have to look at all those right? That all of that data. And how do you point out to people that that's quite efficient already? Maybe you need a rethink. And that's a tricky problem for tools, and for humans, right? Like a tricky
Yeah.
problem, full stop. Things we've tried to do are trying to not provide tips when there aren't any good things to do. Like it's okay to have no tips. If something's fast already, or if something's efficient already, doesn't mean it's fast. If something's like pretty optimal for what Postgres can currently handle, don't like try and give only zeros and say, look, this might be all right already. Or you have to have a rethink. Maybe you're going to need to pre-aggregate, or maybe you're going to have to estimate, or maybe you're going to have to do some other thing like you mentioned.
Yeah, I think it's this. Are you familiar with the concept of like local maxima?
Yeah.
So it's like when you have some of these complex queries, you can optimize little bits and pieces here, but what you've optimized for is a local maxima. And then, but if you totally rethink how you're doing it, you find far away another point that gives you 10 times greater performance for, yeah, I mean, just spitballing here, then it's like, oh, if we totally change how that's kind of what I'm talking about. If you totally change how we're thinking about it, we can achieve this type of performance. So a lot of times, if the solution's not simple, like, oh, this index or partial index or, whatever it may be, I from because I'm speaking from a consulting perspective, I kind of have to like step back and say, all right, let me rethink how we could potentially do this to get, to get the best performance. Or, it's basically the what if scenario. What if we didn't have to use the schema? What if we could do things this way? Or,
Yeah. What if we didn't need this query? Like the best way of speeding something up is not doing it at all. Like, but as a consultant, you have to ask questions to be able to know whether that's even an option, right? Like you
yeah,
have to
yeah,
think, what's the context that this query is being run in? Like how often does that need to be done? Does it change? Does the result change? Like how often does it change? There's a bunch of context you need for that, as well. So yeah, this is why, and also, by the way, we mentioned indexes being like this separate case, but sometimes you don't want to add an, even if the index in this case would speed things up 1000x. This query is a reporting query run once a month and on a really high ingest table that's being like that needs to be able to handle super high peaks. Adding that index might not be a good idea for you in your specific case. Like this is, it's rarer. Like I think we give it as an example for good
yeah,
reasons,
yeah,
but almost nothing in performance is free. Like there's almost always a trade-off at some level, and that's why I find it personally very interesting. But it also makes advice difficult because and you can't just always say it depends, right? Like you have people want some opinion.
yeah.
So
It's
yeah.
like I was just doing a performance optimization for some, or looking into something, and I'm like, okay, I can think of, because they were wanting something in real time, but the amount of data they had to parse trying to achieve real time to get the answer. Like they were using triggers to try to get real time answers to something, storage of data.
Mhm.
But the problem is
Mhm.
they had to go through all of accounts, like in an insert or an update, they had to go through all of these accounts to update something. And they started experiencing problems with updates unlocking. And it's
Yep.
like, okay, we're at the point where something's got to give. So, I gave them, here are the four options. And from a business case, you know, here's ways to achieve it. This will require the most effort to implement. It's the most complex, but it can give you real time data without, causing blocking right. This one is easier to implement, um, but you have eventual consistency. Eventually, the data will be updated. So it's just giving them these options. Is all right. Which option do you want?
Yeah, exactly. And that's where we get the hardest trade-offs, right? At the limits of
Yeah,
things.
yeah,
Um, yeah, and it's great. That's partly why I love it. There's not just like an obvious answer. There's very much which of these do you want over the other one, and you can't have both. No matter how much money you throw at this, you can't have both.
Yep. It's like, when running projects, was it time, cost, scope, pick two or whatever, Yeah, definitely trade-offs.
Yeah.
One thing you had said about the explain is also talking about the importance of testing on realistic sized data sets. Did you want to talk about that a little bit?
Yeah. So this is one of those things that I get is tricky, but it also trips people up a bunch. So we could be like, a lot of the time people are using explain is around looking at, let's say, a production workload. If the server's busier than we want it to be, or we would like to reduce our instance size, or something that's like system wide, it's often very useful for looking at those most expensive queries. But another time it can be useful is when you're building a new feature. But for your new feature, you might not have data yet. There's like test scenarios that you might want to build. On the flip side, if you are trying to speed up one of the like existing queries, but you're working locally and you don't have access to production, you might be struggle to reproduce the performance issues on production. And that's like a multifaceted problem. It's not just query size. There might be other, like, how busy the server. There might be all sorts of other reasons as well, but the primary issue, the primary thing I see trip people up is data volume. So those two cases, one is trying to reproduce issues locally, and the other is trying to build a new feature and basically thinking performance is fine, but realizing quite quickly once it hits production that performance is, or at least on some larger customers, once they have a bit of data, performance is not fine. So the reason for that is the execution plan would, and we mentioned it briefly, I guess, the execution plan changes depending on the amount of data, and that's the big factor. It's normally the number of rows are the biggest factor on which on the costs, on that cost-based optimizer. So the cost of doing certain things is cheaper at the beginning than at the, so how to explain this? Sometimes you have two big costs. One is the cost of getting started, and then there's the incremental cost of each additional row. So if we're scanning a table sequentially, the cost of getting started is nearly zero. We could just start, like, we just start scanning, like start reading a book, open the first page and keep going to second, third, fourth. But the cost of doing each one after that is about the same as the first one. Like, it adds up over time. Whereas an index scan, the cost of doing that first lookup is a bit more expensive. You have to go to the back, have to find it in the index, and then go to the page. So if we just want any one page, we're better off just scanning it sequentially, because we don't have to go to the index first and look it up and things. But very quickly, once we want more than four, but if we want a specific page, or if we want one that contains some information, very quickly our expected cost of looking up in the index overtakes the cost of looking at things sequentially. And the same is true for join algorithms. So if we're joining a very small thing with another thing, a nested loop might be our most efficient thing, because there's very little cost to getting started. Whereas once we're joining more medium-sized things, hashing those in advance, even though that costs a bit more upfront, saves us on that incremental cost of further ones. So it's the size of these relations, or the size of the tables, that is the primary driver in these cost-based decisions on join order, join algorithm, scan choice. And it really trips people up, I think, in two things. One is, this was fast on my dev machine, why is it slow? I had some data, that's the first one. But then it also trips people up in the opposite direction. Like, I've got 100 rows, and I've definitely added the index that I know will make this fast. But when I run explain, Postgres, it won't use my index. Why won't it use my index? Yeah. And that's because even though you've got 100 rows, they're all on one 8 kilobyte page still in Postgres. And it's easier for it to just scan the only page in that table to give it you back, instead of looking up in an index. Like, if someone gave you a one-page PDF and says, "Can you write an index for this?" Like, I'll happily do it for you, but it's not going to save you much time scanning that PDF, especially because Postgres can only, like, the minimum amount it will return is one page.
Yeah, yeah.
What would you add to that?
No, I mean, that's it. I mean, because, as you had said, it's a cost-based optimizer, and it looks at these statistics, how the amount of data, the ratio of data, the cardinality of values within columns to make determination on the plan it's going to use. So if you have a local dev environment, that's going to be entirely different from production. Or even if you have a larger, like a staging area that the data is a little bit larger, it's still not going to give you the same results as production, because maybe that's fabricated data and it'll give you entirely different plans. So absolutely, when I do a consulting engagement, one of my requests is, can I have a replicated copy of production to do my performance testing? Because I'd rather not touch production. But having the copy of the data as it exists, at least from a point in time, removes so many variables from the equation of getting different plans. So, yeah, absolutely.
Yeah, yeah.
So one area that you were talking about also was wanted to talk about is PG stat statements, which that is my favorite extension, given I like to do performance optimization. But what's your experience with using it?
Yeah, I would love to hear more about yours as well. My experience is mostly from people who don't know, like, whose system is overloaded or they have performance issues, but they don't know what's causing it. But I have found it also, like, it is just as useful for, well, yeah, I guess it is most useful for that. But there's like a bunch of specific things you can look for as well. So, um, it's a system view that's off by default as well. I think I'd love to see it on by default, and increasingly I come across customers, friends that are using cloud providers, so it tends to be on by default in most of those these days, which is good. But it's a system view that will track your statements in a normalized fashion. So two queries that, let's say one is select ID from customers where ID equals X and where ID equals Y, those two queries would be normalized to the same query. So you can see which query kind of groups are responsible for the most time spent in execution, or the most buffers that's in there as well, like most IO. So you might be, if you're on Aurora or some other database that charges you based on your IO instead of on like just a standard fixed cost, you might be looking at which queries doing the most IO. So you might want to order by that. So, but I, and probably you, normally order by total execution time. I tend to add planning time to that as well and order by that, but it doesn't normally change much.
Yeah.
So
You
yeah,
know,
it's normally for like. So go on.
no, you bring up a very good point at the beginning where you were talking about on by default, and I was like, yeah, why isn't this in the core? I would really love to have it in the core and just on, and then, I'm sure the concern is, well, we don't want to track too many queries, and I guess it does hurt performance. I mean, it's the Heisenberg uncertainty principle. Basically, you are having a cost on the system by having it on, but it really is quite minimal. And could they just have a very, minimal configurations, like, oh, it just tracks the last 100 queries, something very small in the configuration parameters, and then you can choose to bump it up. But yeah, I would definitely endorse having it as a part of core as opposed to an extension. But
Yeah, I think you're right. I think people are scared of the overhead, and to their credit, or in their defense, if somebody's benchmarking, let's say MySQL versus PostgreSQL, it'd be kind of nice if we weren't putting loads of features on by default that were costing us performance-wise on those stupid benchmarks that don't configure anything. But on the flip side, I think it's for users, for real users, not people benchmarking. It's so valuable, and it's valuable in hindsight. So, if my
Yeah,
system is loaded now, it's really useful to know what's been run in the past, like what has been happening. If I only find out, like if you or I get contacted by a friend or a customer saying my Postgres is on fire, help me, and they don't have pgstat statements installed, we're somewhat like, and if they don't have any logging on, which is mostly off by default as well, it can be difficult to help them. Like you're definitely at a disadvantage, or it takes you longer to help them than it would if this was on by default.
yeah,
But yeah, so I get that it's a trade-off. Like we're talking about, performance is a trade-off, right? But I think normally the performance overhead is worth it. And I've heard, I think I'm stealing this from, I think I heard Jeremy Schneider quote it, and I think it was from an Oracle performance expert, maybe Tom Kite, maybe somebody else. And they said they were asked to estimate the overhead of all of Oracle's instrumentation on performance. And they thought about it, and then they said negative 10%. He said if we had none of this, it would be at least 10% slower than otherwise, because of all the improvements we've been able to make because of this instrumentation. So I thought that was a neat way of looking at it as well. It's like, yeah, sure, there might be like single digit, maybe. I've seen some estimates that it could be as high as 2% on some systems, but I've never been able to measure it. Never, and not even close to 2% for sure for the systems I've worked on. And but the queries we've sped up because of having that on have definitely improved
yeah,
performance overall by more than 10 or 20%. So I like that answer.
yeah, yeah, yeah. Because it's got to be minimal, and at a small instance size, performance, the incremental doesn't matter that much anyway. It's yeah. Anyway, I'm sure others in the community, or at least of the core team, would definitely have their opinions on it.
For sure.
Um, yeah. So, as we start to wrap up, are there any other things you wanted to cover, or any common issues that you see, or common issues that you see developers doing that they could maybe do differently to improve their Postgres experience?
Yeah, let me think. So I would like, if you check, it would be great to check if you do have pgstat statements on already, just in case you ever need it in the future. Pretty simple query you can do. If you even, I think anybody can query it just using show. But yeah, on the explain side, if you're reading them by hand or using like a Depeche style tool, I would highly encourage people to look at filtered rows, not just from sequential scans. So not that when they're looking for index potential, I see a lot of people that see index scan and then ignore it, don't look any further than that. But if an index scan is still filtering tens of thousands or hundreds of thousands of rows, and bear in mind that loops number, that's
Yeah.
still really inefficient. You're still doing loads of work that you don't need to do. So that's a big one for people that are even a bit familiar with this already, that I see a lot of people miss. And yeah, the only other one that is a whole topic in itself is it's worth learning about multi-column indexes, and and how the order matters in those. I see a lot of even experienced developers not understand how much the order of those matters for serving different queries. And if you get the right multi-column index, you can make a single query extremely fast, and you can probably avoid having to add 2 or 3 indexes if you can get the right ordering across those and serving multiple queries with that same multi-column index. So
Yep.
well worth learning about those.
Definitely. All right. So thanks so much for coming on and sharing your knowledge. I greatly appreciate it. I hope you guys enjoy that as well. Please go ahead and like and subscribe. If you want to get more insight into what's going on with the Rubber Duck Dev Show, get notifications of the episodes and the different content that's being released in terms of our videos, be sure to visit rubberduckdevshow.com and go ahead and sign up for our mailing list. Apart from that, again, Michael, thank you so much for coming on. And for everyone else, I'll see you next week. And until then, happy coding.
Thanks, Kristen. Thanks for having me. Take care, everyone.